Okay, now I want to demonstrate this new tool in MATLAB. It'll just take a minute. So I have a set of t data and a set of y data. It's the same stuff we were looking at before. If I plot that with points, it looks like this. Okay, so we've got a few data points here. Y versus X, and we want to fit this to a straight line. Now to do this with the new tool, you can certainly use polyfit and polyval, but to do it with a new tool, you go up here in the figure window to Tools, Basic Fitting, and it brings up this little window. Okay, so in here you have several choices, spline fits, all that sort of stuff. There's a linear fit here. If I press that, it just automatically plots a straight line through those data points. All right. If I want to see the equations, I click here on Show Equations, and I get y is 1.2x plus 7.2. If I need more significant digits, I can get that. Okay. So here's a straight line fit through this data, and you see it's a decent fit, nothing special. I can add a quadratic to that. You can see the blue line here is nearly on top of the straight line, so there's not much help to us here by adding a quadratic, and which indicates that the data in itself is actually fairly linear. I can add a cubic. Okay, and again, there's very little variation, so a straight line fit is as good as any of these here. Now at some point, we can add 4th degree, 5th degree. You can see the fourth degree gives me this wiggly line because there's only 5 data points, and so 4th degree and 5th degree polynomials don't make much sense. 4th degree would fit exactly through every point, so it's not a least squares fit at all. It's an equation for the polynomial that goes exactly through those points. And 5th degree doesn't make any sense because we've only got 5 data points, and it just doesn't make sense to have 6 constants for 5 data points. Okay. You can plot the residuals next to those. So the residuals are the squares of the errors. You can see the biggest error is associated with this point here, right here. Sometimes that's useful. We can have, a scatter plot for that if we prefer. So here these data points represent the residuals. I can get rid of that. There are some other windows here. I can click this arrow at the bottom. This shows me the polynomial with the coefficients and the norm of the residuals. That is this f we've been talking about before. And then in this last window, we can evaluate the function. So we can put in something like 3.32, evaluate it, and this will evaluate the straight line fit at x equals 3.32 and give you f that from the model. Okay, and you can even plot that data point on the plot if you so desire. Now it put that at 3.3. It put in what we get for the model. Okay. So that's basically how this works. It's a pretty nice tool for doing curve fitting if you need polynomials. Otherwise, you can use linest or polyfit, or you could even do the nonlinear stuff in MATLAB if you want. All right, so that's all.